Hello. For this lesson in using sample code or using code to reverse engineer back to specs, I'm starting with sample source code from the book Pro.NET Best Practices. And what I did was I went to the GitHub at Ruthless Help, and in that repository, Pro.NET Best Practices, there is a chapter 8, which has an example of using this application. It's called the Lender SLOS, and it's a student loan system. And I'm just starting with the C# code, and I'm going to see if I can, in a chat session, reverse engineer this code and understand how it works. So I have a README here just for this presentation. I'm just going to go ahead and remove that in case it even provides a hint there. And we'll start, it's nothing but C# code. If we look through, we'll see this code base just provides various solution models and various things. So I'm using agent mode with GitHub Copilot and Claude Sonnet 4. So the first thing I would like to do is understand what the requirements are. So I will say something like, you are an expert in reverse engineering code and providing, let's say, specifications. Review this code and generate the product requirements document in a, we'll say, docs/prd.md file. So now the agent will start reviewing the code that's in this code base and see what it can do to determine what does this all mean. So it's going to start generating a product requirements document. And the first thing it determined is that this is a loan application, student lending financial calculation. I'm not going to install the C# language kit just yet. I just want it to review the code and make meaning of the code. So it's going through each of the C# files, and it's trying to understand how it all works. It's trying to make meaning of all of these files and figure out how various and hibernate mappings work, which is the way in which it does a object to relational mapping. And now it's working on that PRD. It's putting it in the docs folder. So it takes it a little while to go through and produce a result that will be something useful that we can look at. So now there is a PRD file that has been generated. And then it's going to give me a summary of what all this means and how this all works. So I am going to keep the document. Well, let's take a look at it before I press the keep button. So it'll give me a rundown on what this is all about, different sections of this file and how it all looks. I'm going to go back and say keep that. Now I'll say generate a system design document and save it in, again, we'll do it in docs / we'll say system design.md. So now it's going to take everything that has been generated so far and going to do more in-depth technical analysis. While it's running, I'm going to go ahead and look through this PRD file. So it correctly identified that this is a student loan origination system. It's going to go through and understand its purpose. So student loan applications, it's a student borrower loan application, financial payment, and data persistence are the key elements. We have loan officers, financial administrators, and system administrators as the target users. It talks through some of the key benefits. And it talks about the various things that the student management part of the application does, how the portfolio profile is saved and retrieved. It goes through how the application is created, how it's retrieved and updated. It talks about the payments and how the payments are calculated, and how it converts the input into monthly payment, and how the principal amount has to be validated. And it goes through various date validations that are in the code. For example, the date of birth must be in the past. Date of birth must indicate the borrower is at least 18 years old. These are student loan requirements that the application enforces. And it provides some general architecture information, including the technology stack and a database schema. So now the agent is wrapping up here. It's describing a little bit of how everything works and how that process. So we'll keep that. And let's take a look at that design document. Here, it's going to go into a little bit more into the visual representation of the application and how SQL Server and Hibernate play into it. It's going to look at each one of these components, tell me about its purpose and its meaning. The last thing I'm going to do is generate some test cases. So generate a test plan document in the I'm going to create a new file called testplan.md. Now, you notice I'm using Markdown. And my Markdown choice is because it's a structured way for the agent to generate content. So the Markdown format is very useful, and it gives us a way to look through the code base, for example. And now this code base just happens to have a lot of tests in it. So hopefully it will understand those tests and come up with a test plan based on that. I'm going to go back and look at my system design document and understand a little bit of how it goes into the object relational mapping and database abstraction. There's this idea of a session and the use of generics to do the repository implementation. It also looks at each of the application domain model and how an application contains a student, which has a school, and how the repository pattern is implemented. It lists out design patterns that have been applied, the repository pattern, the factory pattern, the data mapper pattern, and the domain model pattern. It explains how all of these relationships work. An individual and a student have a one-to-one relationship. So there are other people in the system. There are parents and references. So the individual and the student have a whole part relationship to them. Table specification is identified. It gives examples of how session is managed. It explains how transactions are handled and how the caching strategy works. It also talks a little bit about authentication and authorization, how performant it is, and it provides more detail in the technology stack using NHibernate 3.x and how it uses SQL Server Client. It also talks about external dependencies and how those external dependencies relate to the code. It also looks at the deployment architecture. How is this going to be deployed, and how is it going to be configured? It also talks a little bit about error handling within the code and how that takes place. A lot of it is through the use of guard clauses and exception throwing. It also talks a little bit about the business rule validation and then the testing strategy and how the tests are organized. I'm still working on those tests, and the agent has gone through and created comprehensive information about the testing structure, and now it's going to write a test plan document. There's more discussion about how the code is organized. Namespace is a feature-based namespace, and the assembly structure is the layer-based assemblies. So that gives you an idea of assemblies are used to create layers, and namespaces describe features. There are some tables that are generated. What I'll do is, let's see if I can look at this from a markdown viewing perspective, so you can see how the tables are organized. It gives some sense of how we might do performance benchmarking and how we might summarize some of the architectural patterns. Let's go back to the agent. So the agent has now created this test plan document. I'm going to go ahead and keep it so we can take a look at it. Okay, so it's going to talk about the testing objectives and the strategy. We're essentially going to take multiple layers here, end-to-end workflows, surface tests with database. So there's a way to test the database, and there's a way to isolate components. And it talks about the different categories that are in this code base and the testing principles behind them. And it talks about the frameworks that are being used to do the testing and how the tests are organized in the different solution files. And it talks about various testing patterns that are employed and goes through each one of the different tests that are going to want to be run. Okay. So that is an example of how you would go through a code base and come up with 3 different documents, product requirements document, system design, and a test plan. Thank you.